Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my lecture video. Okay, today's topic is wages. Okay, so if you missed my previous lecture, so you can check the link in the descriptions down below. Okay, so for wages here, so what is a wage? Okay, a wage is something that we use to maybe a stopper for the door. Okay, for example. Okay, and in this situation here, okay, just like this figure here, okay, we use a wedge here like this. Okay, because we want to move this block here upwards direction. Okay, as you can see here, when we apply a force like this to this wedge, this is a wedge. When we apply like this wedge will move to the to the right side. Then this block here will move upwards. Okay, so in wedges we are going to find the value of P so that the block can be moved upwards. So how to find it? First of all, we need to have the free body diagram. Okay, let's draw the free body diagram first. Okay, now this is not the perfect free body diagram because we still have more forces, okay, to draw. Now let's look at this wedge and also this block here. Okay, so in this kind of situation, when you want to draw the free body diagram, make sure you draw the part that has the external force first. Okay, so in this situation here, okay, the external force we have is at the wedge here, which is this P. Okay, so let's draw the free body diagram of P first. So if you look here, this wedge here made contact with this floor here. So if it made contact, means that it will have a reaction force. Okay, so if there's a reaction force, so in friction here, the reaction force will be normal force and the friction. Okay, so we will have normal force. So normal force again must be 90 degree with the surface, this one. Okay, so friction. Okay, friction is perpendicular to this normal force. But what is the direction of our friction? Which one? To the left or to the right? Okay, refer back to our external force. So because our external force is pushing to the right side, okay, pushing to the right, means that friction must be working on the opposite direction, to the left. Okay, so our friction will be this one. Okay, so this is our friction. Okay, so next, do we have any contact in this area? Look carefully. No contact, so means that no normal force, no friction. Do we have any contact on this surface here? Yes, we have. Okay, this wedge here made contact with this block here, so it means that it will have normal force 90 degree also. Okay, 90 degree, this one. What about the direction of the friction? Again, because we want to push it to the right, so the friction must be to the left. Okay, so this one also, friction is to the left. This one, normal force. Okay, so if you look carefully, we have two normal force and two friction. Actually, these two normal force here is not equal to each other, different. Okay, so means that we need to label it differently. Okay, let's say we label it as NA and this one is NB, for example. Okay, and what about F? So we follow the normal force lah. So F here will be FA and this one will be FB. Okay, so finish the free body diagram of the wedge. What about this block here? Okay, so again, if the surface made contact with other surface, when we want to make it free body diagram, make sure you need to have the reaction force, which is normal force and also friction. So here, as you can see here, okay, as I mentioned earlier, this block here made contact with this wedge, this one. So means that it will have normal force and also friction. So here it will follow the surface like this one, okay, normal force. So this one here, because this surface made contact with this surface, the normal force here is actually the same normal force, this one, okay, because it is in equilibrium, okay, push each other, because the upper part here is pushing, for example, 20 Newton, lower part also must be pushing 20 Newton also, okay, must be equal to each other because it is in equilibrium. So it means that this one is also NB, below here is also NB. Okay, what about friction of this surface here? So to the left or to the right? Which one? The correct one is to the right side. Okay, why right side? Because as you can see here, this one, okay, as mentioned earlier, normal force here must be cancelling each other. So friction also must be cancelling each other to make it equilibrium. So we have this one. Okay, the friction must be to the right. To the right. Okay, opposite to each other. Okay, so next part is this one. Okay, do we have any contact in this area on this surface here? Yes, we have this one. Okay, we have here. So meaning that this part also will have reaction force, which is normal force and also friction. Okay, so the normal force will be this one, and also friction. What is the direction of the friction? So again, okay, look at this image here. When the wedge is moving to the right side, this block here will move upwards. Friction must be, the direction of the friction must be opposite direction of the movement. So means that if this thing is moving upwards, so friction must be moving, acting downwards. Okay, so this one will be acting downwards. Okay, F. Okay, what about the labeling? Okay, this one is A, this one is B. So this one should be different normal force. Okay, so this one we can label it as C. Okay, C, and this one is C. Okay, so this is how you draw the free body diagram when we have a wedge. Okay, so it is not only for a wedge. Okay, let's say we have two blocks. Okay, up and down here. Okay, when we want to find the force needed to move the block, okay, and we need to draw the free body diagram, it is the same. Okay, same for this one here. So make sure you start drawing the free body diagram where we have the force. Okay, the force first, so that we can draw the correct direction of the friction. Okay, if we start from up here, we cannot know, okay, we cannot know the correct direction of this friction here, FB here, this one. Okay, so please make sure you draw from the part that has the external force first. Okay, so in the next lecture, I will show you one question, okay, regarding wedges, and I will show you on how to calculate this force P here, okay, to move a block, okay, using a wedge. Okay, so please check my next video. See you again in the next video. Bye bye.